So, welcome everyone. This is our advanced micrometer talk. I can say that.
Yes. Hopefully that's what everyone is here for. If you're not here for that, you should stay anyways, because it'll be fun.
So let's introduce ourselves. Hi, I'm Jonatan. I work in the Spring engineering team. That means mostly micrometer, but sometimes I work on Spring Cloud and Boot projects as well.
And my name is Tommy. Basically, same thing. We work on the same team.
Yep. This is basically the 2/3 of the Spring Observability team, what you can see on stage right now. So this is our agenda. Do you want to take that?
Sure. So last year at Spring I/O, we did a micrometer talk where we kind of covered the basics and showed you what you get out of the box as far as observability with Spring apps and micrometer. And we kind of wanted to follow it up this year with a more advanced talk that built on that for people that wanted to know more and understand how things are working under the covers with the instrumentation. And if you want to write your own instrumentation or customize anything, this is what this talk is for. So if you are not familiar with micrometer at all, this might be a bit difficult of a talk for you. We are going to try to recap things as much as possible, but this is kind of targeting a more advanced audience.
Watch the talk that Marcin and Tommy did last year on Spring I/O. This is pretty nice, and this is kind of the continuation of that. So with that, let's do some recap around like observability. Let's cover the basics. For this talk, we will define observability like this. It is basically how well we can understand the internals of the systems based on the outputs that it provides. And this is just a fancy way of saying observability is basically data about your application. What data? We will cover some of those scenarios. But let's talk about why do we need it, because this is rather important. In one word, because of complexity, because today's systems are insanely complex. If you have heard about Death Star architecture or Big Ball of Mud, that's what we are talking about. If you haven't, look at these images. If you need to troubleshoot something in this infrastructure, good luck, I guess. And also, this is a part where the talk will get into like a darker direction. I'm from Eastern Europe. We are very pessimist. So if you need to troubleshoot something in this, it's not very fortunate, but it's a little bit worse because on this scale, something is always broken. Also, these environments are very, very chaotic, which means that you turn up here a little, and in another region, services will go down. Also, we need to deal with unknown. We cannot know everything. There are things in your environments right now that you don't know about, and they take down production, or can take down production. Eventually, they will if you let them run enough. And also, things can be perceived differently by different observers, which means that maybe 100%, everything is 100% fine from your perspective, but at the very same time, maybe everything is broken for your users. I warned you, this was the dark part. But let's also, wait a second. Oh, I just skipped the slide. Never mind. So let's talk about the business perspective as well. And the one-word answer for why do we need observability from this perspective is money, I guess. So we can reduce the loss of revenue from production incidents just by being able to troubleshoot them faster, and hopefully with that fix them faster. And also, this usually needs like less specialized knowledge. So you don't need like a separate tool for every single applications, and also you don't need like some tribal knowledge for some like special applications who also have a soul. You all know this. I think you have those applications in your like production infra as well. And also you can quantify user experience, which means that you don't need to guess about like what your users are experiencing. You can measure it directly by using observability tools. So we gave the definition, which did not include this. So logging and metrics and distributed tracing are very, very important signals in the umbrella of observability. This is not the end of the story. There are way more things, but we will talk about these briefly because these are the most popular ones, important ones, if you will. So if you want to implement logging with the JVM or with Spring Boot, we usually recommend using SLF4j with Logback. SLF4j is basically a simple facade API over logging libraries, so you can plug them in and out. And Logback is one of the implementations, but if you want to replace Logback to, like, let's say Log4j, in Spring Boot, this is just like excluding a dependency and bringing in another one. by default you will get logback. If you want metrics, we usually recommend Micrometer, which is a dimensional metrics library on the JVM. And it is kind of like the SLF4J story. It has an API which is independent from the metrics backends that you want to use. So you can plug them in and out. You can use multiple ones at the same time if you want. And it supports many, many backends. Spring Boot Actuator comes with it, like for free. And also Spring projects are instrumented with Micrometer. We have auto instrumentation for most of the Spring portfolio using Micrometer. But we will talk about that later a little bit. And also, like, there are many third-party libraries that are also instrumented using Micrometer, and the list is like very long. If you want to do distributed tracing with JVM or with Spring, then we need to make a distinction here, because if you are still using boot 2.x, first of all, I'm a bit sorry. And second, the distributed tracing solution is Sleuth, Spring Cloud Sleuth. And if you are using Spring Boot 3, then the distributed tracing solution that we recommend is Micrometer Tracing. And Micrometer Tracing is basically Spring Cloud Sleuth, because what we did, we copied Sleuth over under the Micrometer umbrella, renamed the package, removed the Spring bits, so Micrometer Tracing can work not just with Spring, but with any JVM application. And we also moved the instrumentation that lived in Sleuth into separate projects. So the instrumentation for Spring MVC, guess what? It lives in Spring MVC, which sounds reasonable. So both of them, Sleuth and tracing, or sorry, Micrometer Tracing, they provide an abstraction layer over tracing libraries. It is also the SLF4J situation. You can use like the tracing library of your choice under the hood. And we support two of them. One of them is called Brave, and the other one is called OpenTelemetry. And Brave is kind of like a default, except there is no default because you need to choose. But Brave is the more mature product. OpenTelemetry is not entirely stable yet. So we usually recommend Brave for production. Also, Spring projects are instrumented with these, and there are also like third-party libraries that have instrumentation. And because these two libraries, tracing libraries, Brave and OpenTelemetry, because they support various backends, that's why Micrometer Tracing also supports various backends, which is a good thing. Okay, let me give you a very short demo. This is our award-winning UI for making some tea. And you can tell that we are not front-end, but back-end engineers by looking at this UI. And the last time, like Tommy and Marcin, they showed this UI. So we made a big improvement since then based on user feedback. That's the Spring logo up there. Right? It was a lot of work. Thank you. Thank you very much. So if I just click this tea button, I will get a recipe for a large sencha, which is great. But if I want to drink English breakfast, then that's not good. So let's look into what happened. And if I look into, you know what, let me go to the logs, because that's what usually like I believe most of the people do. So if I query, let's say, the last 5 minutes of the logs, and let me also set the label to tea house. So this is what I did to just query all of my applications. Then hopefully I should get some errors. Nope, there are no errors here. So let me also look for errors. Level equals error. I have one. So here I can look into like what really happened. And maybe based on the logs, I will be able to kind of reproduce the architecture that we have, which looks like this. So we have an application T service called by the user, calls tea leaf and water over HTTP. They have their own databases, which is great. So if I look into the logs, what I would like to demo, how to jump between these signals. So what we are going to do, because we have auto instrumentation in Spring projects, and we have like a bunch of features, including row correlation. That means that the trace ID and the span ID, the distributed tracing information, it goes into the logs. So what I can do, I can copy the trace ID and the span ID from the logs, and I can just jump from our logging backend to distributed tracing. And in distributed tracing, I can just troubleshoot this further, and I can see that T service did like a make T, this could be the business logic, and there was a T-leaf service call as well. What is red? That one failed, like the red icon. So if I look into this, for example, the database query, let's see what happened here. Nothing much, it's a select query from the database. Let's look into the result set. And well, it failed. Can you see this? JDB 0 count 0? That's bad. That means that I forgot to put that record into the database. So you can use this to quickly troubleshoot things. But you cannot jump just from like logging to tracing. Nothing prevents you to jump back. So I teach Grafana how to do it, and basically you can copy the trace ID from your distributed tracing backend, and you can put it into your logs, and these are all of the related log messages for that error. So you can see from all of the services, which is a nice feature. But because the toolset that we are using, called the Observation API, which Tommy will talk about, that kind of forces everything, every metric data point to have the same tags or key value pairs on them, and those will present also on your spans in your distributed tracing backend. You can jump between spans and metrics by just copying and pasting those tags. So if I just do that, I teach also Grafana how to do it, and if I just go to throughput, then I should see a time series here, like a graph, which basically all the similar traces, method equals cat, exception not found, status 500, which is also interesting, but why it is like 500 and not found. But you can get that information out of the tracing. Why is that? And also, you can do one more thing. You can jump from metrics to traces as well. So if I go to one of our dashboards, if I find it first, then you can see there are these graphs. This is a latency graph, which doesn't really interesting right now. What is interesting is that all of those other like small data points, those are called exemplars. And the exemplars are kind of like metadata that you can attach to your metrics data point, to your values, and they can contain things like trace ID and span ID. So you can jump from metrics to spans. And this is kind of like a hard problem, because if you think about it, what happens here is that let's say that you have like 1 million like requests coming in a time window. From that 1 million requests, you aggregate them to one single number, let's say 100 milliseconds, maximum latency, or 90. How can you get from that number, 90, back to one of the 1 million spans? Like this, you can use exemplars, which is sampled data, which contain the trace ID and the span ID. So if I open one of these exemplars and zoom out, I can just jump to my distributed tracing backend, and I can see what caused the problem, which is a really nice feature, if you ask me. So this was the recap part, and we will talk about this concept a little bit later. Are we done with it? Do we have anything else? Tommy, can you show us how to customize things if we have something like this?
Yeah, I think we have something that can do that.
Okay.
By the way, I know that Sergi said in the opening ceremony that there were supposed to be no memes, but don't tell him about this.
We are
one.
violating
Hopefully
that.
he doesn't watch the recording. But so if you watched the talk from last year, hopefully that was all very familiar and kind of a recap of things. But so we wanted to go deeper with this one. We wanted to say, okay, but what if you have some custom components that are specific to your company that are not going to be instrumented out of the box by the Spring team or open source libraries because it's not open source? Or what about if you want to customize some existing instrumentation that you're already using? So for that, we have this thing called the Observation API. And it's actually been released for a little while, and we haven't talked about it too much, and so we wanted to take this opportunity to do that. So traditionally speaking, if you want to instrument your application, what you would do is you would use a logging API like SLF4j, add logs to your application, and then that's, a lot of developers are familiar with logs. But then they learn about metrics, and they're like, oh, that sounds really neat, and it probably costs a lot less than logging 1 million logs per second if you have 1 million requests coming in per second. So then you want to add metrics. Well, now you have to use a metrics API and instrument the same code that you added logs to earlier, and that's pretty neat. And then you learn about distributed tracing, and you're like, well, this is really cool. Now I can follow my request throughout my whole system through each of the components. But what do you have to do then? Well, now, again, you have to use a tracing API and instrument the same code that you instrumented already with logs and metrics and now tracing. So we thought there has to be a better way. And that's where we want to introduce to you the Observation API. So this was a new module added to the Micrometer ecosystem in a module called Micrometer Observation. And this was added in Micrometer 1.10. And Micrometer Core has a dependency on Micrometer Observation. So if you are using Micrometer Core, you already have a transitive dependency on this. Observation API is already available to you. And what it is it's trying to be a higher level abstraction for when you want to time some operation. So if you're trying to instrument something, you want to see how long a method takes. You might have been doing that already with log statements, saying, okay, I've started executing this code, and then at the end say I've stopped executing this code. Or with metrics, you may be timing that with if you're using Micrometer, you might be using a timer and starting and then stopping. Or if you're using tracing, you'd be doing the same thing with a span. So this is kind of taking that and abstracting it to a new API called the Observation API. And the idea is that you want to be able to instrument once with one API, and then you can configure arbitrarily many handlers that can give you things out of that, like metrics, tracing, and logging, and anything else that you can think of. And we have some interesting things that we might be able to show you later. And you may not be aware, but most of the instrumentation that you were shown in that demo and that you've maybe seen in your own applications that are using different Spring projects are already being instrumented with this Observation API that we're talking about. Under the covers, that's what they're using, and that's how you're getting the metrics and traces out of all of the Spring projects. So, basic API usage example, should look pretty familiar if you're familiar with like a micrometer timer or a span in a tracing API. So observation.start, and you pass it a name. In this case, talk is the name of the observation, and you pass it a registry, an observation registry in this case, which is very similar to a meter registry from Micrometer's metrics API. And then in a try-catch finally block, you're going to do something, and this is the operation that you want to time. And in the catch block, if there's an exception, you're going to add that to the observation, so it is aware that an exception happened and exactly what exception that is. And then in the finally block, you're going to make sure to stop the observation. Pretty simple, right? But if you do just this and you don't have any handlers registered, this actually does nothing. You're starting and stopping an observation, but if there are no handlers there listening to this happening, you're not going to get anything out of it. But if you're using Spring Boot and you have the right things on your class path, then Spring Boot auto configuration is going to kick in, and it will register a meter handler, and it'll register a tracing handler, and that is how you get metrics and traces out of the Observation API that's already instrumenting the various Spring projects. And if you wanted to make your own custom handler for anything that you want, Spring Boot will auto-configure that too, so you just make a bean of observation handler type, and Spring Boot will automatically configure that on the observation registry. So, hopefully that makes some sense in the abstract, but let's look at some actual code, and we're going to use the same application that Jonatan just demoed for you, and we're going to go to the T controller. Hopefully everyone can see that. So the T controller is what that UI that we were looking at in the browser is calling. So it's calling this get mapping on the T controller, and that's just using this T service thing here to eventually call make with the name and size that you are passing to that controller. And this is where T service is kind of where the business logic of this is going to exist, right? And we have out of the box instrumentation for HTTP endpoints like REST controllers. And that is great, but that doesn't have the specifics of your business logic. In this case, we're taking in a name and we're taking in a size, and we want to be able to include that into our observability data. So we want to instrument the T service, essentially. And how do we do that? Well, of course, because we are all very enterprise Java developers here, you can't just, you could just add it to an implementation or a concrete class called T-service, but it might be nice to separate your business logic from your instrumentation, right? You want to be able to write a clean clean code that just has your business logic and doesn't have the observation stuff mixed into it. So in order to do that, we're going to have an interface, tservice, and then of course we're going to have a default implementation of that interface, and this is where your business logic is going to exist. And then if we want to instrument that where we don't want to get the observation API mixed into the code with your business logic there, we can have this observe tservice that just delegates to another implementation of tservice and basically wraps that in an observation API call. So you can see that tservice make call that we had earlier. This is going to use the observation API and then eventually call this observe method to delegate to the actual class that has business logic for tservice. And you can see that it looks a little bit different than what I showed you on the slide there, but it's more or less the same, right? So we have observation create not started, you're passing a name, you're passing the registry, but then you're adding these low cardinality key values. And here we're saying key values, but if you're familiar with the metrics and tracing APIs, these are basically tags. And in here, with the observation API, we're distinguishing between low cardinality and high cardinality tags, which is an important distinction for metrics and tracing. And so here we're just adding that business data, name and size, and we're tagging that. And then we're delegating to the tservice, as I said, but we're doing it inside this observe method. And so this way, we don't actually have to start and stop and add the exception if there's an exception thrown. Calling observe here is going to handle all of that for us. And so in this way, we just have a very simple way to wrap some existing business logic. And this is the code that was actually shown, and you saw that in the tracing data, it showed up as a make t span in the tracing data. So this was already there in the demo that you saw, and that's pretty great. But let's talk about some more things that you can do. So we talked about how there's out-of-the-box instrumentation that exists already, and maybe you want to customize that existing instrumentation. So maybe there's some noisy instrumentation from some library that you're using, and you don't want all of that observability data. So we have an observation predicate, which is a byte predicate that takes a name and a context and returns a Boolean that says whether you are going to enable or disable that observation. So if you return false, then that observation is going to be disabled. You will not get any observability data out of that. And this is good for turning off noisy observation in some library that you don't want observability data for. Observation filter is similar to a meter filter, if you're familiar with Micrometer's metrics API. And this is for modifying an observation context, which I'll talk a little bit about later, but this is just a way that you can do things like add common tags to all of your observability data. So let's talk about conventions. Instrumentation by default has conventions. It decides on a name for an observation, and it decides on tags that are on that observation. And this is great, but sometimes you want to customize it, and you don't want to have to rewrite the entire instrumentation. You don't want to throw that all out and just write it from scratch because you don't like the name that they use for the observation. It doesn't match what you're using elsewhere in your company. Maybe your company doesn't use all Spring Boot applications. Maybe you have some Golang applications, and those are using a different name for their observability data, and you want to make things match. So there needs to be some way to customize this. And also, maybe the conventions that you use in your organization change over time. Maybe you want to realign things when you introduce something new or switch to some new convention. But you need to be able to control the timing of this. You don't just want the instrumentation you're using to change suddenly, because that's a breaking change. If you have metrics dashboards or you have alerts that are based expecting a certain name to be there, and then that name changes when you upgrade versions, everything's going to be broken, right? Your dashboard's not going to display metrics, your alerts are no longer going to fire properly. And so this isn't like an API change. Your code's not going to fail to compile, but you will start losing things, and you need a way to control that. And so for that, we, along with in the Micrometer Observation module, we introduced the concept of an observation convention. And instrumentation can use this, doesn't have to. So the example I showed you earlier, you saw there was no convention included in there. We're just directly saying, here's the observation name, here are the tags that we have on there. But you could use a convention and have some default and then allow users to pass to your component an observation convention implementation of their own that will be used instead. And that way it allows this customizability of, I'm providing a default, you can override that, and you could even extend the default implementation that is being provided by that component. And so I have a link here. You can check out Spring Framework's documentation if you want to see, like Spring Web MVC has this documented on how you can customize their instrumentation. And then I mentioned earlier that I'm going to talk about observation context. So observation context is just holding the state data of observation. So the most probably clear example for everyone would be if you want to instrument a HTTP request, say on the server side web MVC, something like that, then you probably want your observation to be aware of the request and the response so that you can then tag interesting information about the request and the response. And this context will be passed to the observation handler and any observation handlers that are registered, and it'll also be used in observation conventions. And this is mutable. You can add data to it at instrumentation time, and also the handlers get called, say, when observation is started or stopped or when error is applied, and you can also get past the context there, and you can add and modify data at that time. So let's go back and look at some code and maybe apply some of these concepts. So we don't want to just do everything kind of hard-coded in there. We want to be a little bit more flexible. So I conveniently have some commented out code here. So this observe T service, which is just wrapping another implementation of a T service to add observability to it. If we look at the constructor here, you can see that it's taking the delegate that we're delegating to, the registry for the observation registry, and it's also taking this custom convention. So in this way, we're allowing users to be able to pass their own observation convention that will override the default that we're using. And you can see it has this static final default convention. And if we look at that and zoom in a little bit so you can see, close this. You can see that this is a T convention, which is just an interface over an observation convention that takes a make T context. So that is the observation context that I talked about earlier. And if we go back to the default implementation, you can see that this overrides the get name to say, I want the name of the observation to be make T. And then you can see that it is saying the low cardinality key value should be T name, and you should get the value of that from the context. And water size, again, get the value of that from the context. And you can see that make T context takes a T name. That should have been water size, not T size, but if you ignore that.
After you brew a T, the water size is the T size.
There
Saved. It's not a bug, it's a feature.
So in this way, you can see that there is a default T convention, but a user could create their own implementation of make T convention, or they could even extend the default and only customize the parts that they want. And so this is a little bit more powerful than what we showed earlier, where here we were hard coding things, right? So now we're taking the custom convention and we're considering the default convention, and we now have this context object, which we also didn't have before, and we're passing to that the name and the size. And then again, we're calling observe. So a lot of this is very, very much the same, but we have more power now. And if you want to look at how this can be set up as far as where we're declaring the bean. So you can see we have the T service bean that is being injected into the controller earlier, and we are making that observed T service, and we are taking a custom convention if there is any provided, and if there isn't, then it'll fall back to using the default convention. So this way, if some library had this kind of setup, you would just register a bean of the correct convention type, and then that would be automatically applied. And this is generally how that works. And so this, you should get exactly the same results because we have the same thing that it was in the hard coding, but now it's in a convention and it's more easy for users to customize that. Okay, so that was pretty neat, but let's talk about documentation. So we also, at the same time that we released the Micrometer Observation module, released another module called Micrometer Docs Generator. And the problem that we're trying to solve here is that you have this observability data now, but you want to document it because people need to know that it exists and what the values are. But it's very error prone to do this, right? If you're going to handwrite documentation, what happens when you change the code? How do you make sure that those two are in sync? This is maybe a familiar problem for people if you're documenting APIs that you expect other people to call. And so we wanted to see if we could do something, make this better for observability, and that's where the Micrometer Docs Generator comes in. And the way this works is there is an observation documentation that you need to define, and it's going to be defined as an enum, and then you are going to use, at build time, the Micrometer Docs Generator code to generate an ASCII doc file that documents what is in that observation documentation. And of course, you need to make sure that you're actually using that observation documentation in the instrumentation, and so you integrate it with your observation convention. And we can go back to the code again and comment this out. And look at this very conveniently right here, make T documentation. So if we go take a look at this, you can see make T documentation implements observation documentation. And I mentioned it's an enum, and this is a little weird, but we have to do weird things if we want to be able to inspect things at build time and get values out of stuff. So it's a little weird, but bear with me. So in the enum, you have make T, and this is representing an observation that you want to document. And in the Java doc is where you put the documentation. So we're going to say the description of make T is make some T. And then in here, we're going to define what the default convention is. So that's going to be documented. This is the default convention. And then we're going to document what the low cardinality key names are. And you can see that we're doing that again here with an enum that implements key name. And then again, JavaDoc, you can document exactly what this key name means and then what the value is. So T name here, water size here, and again, JavaDoc. So that's all well and good. And you can see that the API looks very familiar. So now you're using that observation documentation, and you're calling .observation to get an observation, and then on that you're calling observe. And so basically everything looks exactly the same as here, except now you're using the documentation. But wait a minute, we need to actually make sure that the implementation of our code is using the documentation so that they don't get out of sync, right? So let's go back to the default make T. And again, super convenient. There's just this code that's commented out right here. Comment this out. And so instead of hard coding into the convention, now we can reference that make T documentation and the key names, and then we can use that key name with value from the context. So we're doing exactly what we did before, but now we're making sure that what is in the documentation is definitely matching what is in the implementation of the default convention. And hopefully that is the right task. Yes. If we run the task that is in the build, we should, in our docs, have an index that will then refer to a couple of ASCII doc files. And this is what you get out. And none of this is handwritten. Well, the handwritten part is just this, which is including a few other files. But those files were generated at build time based on that observation documentation. And so now you can see here are the conventions. You can go down and see what metrics would you get with the default metrics handler. And you see the make T with the description, and then you go to the keys and you get the key names and the description that was from the JavaDoc in there. And then you can see if you have the tracing included, then here's what you would get in tracing. And so you get all of this generated for you. You don't have to keep them in sync by hand. And then you can include this in your documentation and provide it to whoever needs to see that about your observability data. Pretty neat, hopefully. And so I hope that T-service instrumentation was close enough to real world for everyone, but if you want to see something even more real world, Spring is open source, so anyone can look at the instrumentation that we have for the various projects. And if you're interested in Spring Web MVC or REST template, we have links in the slides here, and we'll make the slides available, and you can check that out later if you're interested. So with that, I think
Let's
Jonatan
do another
has
demo.
time for a demo. I mentioned that Observation Handler, we of course have default implementations for metrics and tracing, but you can make an implementation for anything. Anything. Maybe some things that you even shouldn't make implementations for.
Or at least not in production. You remember like when Tommy showed how to basically like create, start and stop observation and also signal an error, and also that you can what he mentioned, the handlers that you can register and they will basically like listen to these events. When somebody starts an observation, they can also start an observation. Listen on the on-start event and do something. When somebody stops an observation, they listen on the on-stop event and do something, and so on. So if you, let me stop these. This is a load generator which is running, and that basically created some traffic for us. But let me show you how to, the sheer power of this. What are the things that you can do with this? So let's start and write a observation handler. So if I create, first of all, who knows what MIDI is? M-I-D-I. Yeah, that's cool. Okay, so that is the musical instruments interface that you can use for a bunch of things. Believe it or not, Java has support for that. So if I create an observation handler that will play a note or a random percussion, where is it? Here. It will play a random percussive instrument for the duration of processing that incoming request when the request was successful. And if we play the French horn, if there was an error, and also to make this a little bit worse, better, I don't know, if I just initialize a bass guitar here, and I will play the bass, a random note on the bass, when there was an outgoing HTTP request. And let's say I should have one more. So let's say I also want to play the piano when there was a database call. So if I do all of this, and hopefully this will work, then you should hear something like this. This is basically observations converted to music. So I want you to listen to this, and I want you to listen to the French horn, because I am going to create some errors. Try to listen and try to get from the three instruments which one is the French horn. Do you hear it? Yes? The ba. Okay, cool. So let me just put back some load. And let's hit this with some load test. Let's see what will happen. Did you hear the French horn? No? Let me give you some visual clues. So every single tile is processing a request. Green is successful, no French horn. Red is failed, French horn. Come on. So you can hear the throughput, and also you can hear the error rate.
Who needs a dashboard anymore when you can just look at
this?
Yeah,
you can just listen to
hear it.
So another thing that we can do right now is that these applications, they are not connected to the database directly. They are connected to a thing called Taxi Proxy. And let's see what happens if I introduce some latency on the network. So what I will do, put the music back. I will just issue a command. It will introduce some latency. Please listen to the pace of the music, to the rhythm, where you can, if you can hear when the latency will kick in. Then I will run it for a few seconds, and I will remove the latency. And please listen if you can hear when the service is back to normal. So this is basically application torturing. Let's see if you can hear the application is struggling. So music is back, latency in, latency out. Did you hear it? That the music slowed down? Let's do it again. So I guess this is called observability, as you have never heard before. Pun intended. I have other people had ideas around this. Somebody integrated async profiler through this observation handler. And there was I'm not sure if he did this, but there was a guy on Twitter who wanted to integrate this with like a library can generate you UML sequence diagrams. So catching those observations or listening those events, you can, well, I think it should be possible. You can generate like UML sequence diagrams, for example, from tests. Also, with this one, because like if you look at the dashboard, you can see what is happening. Now you can hear it. I have future ideas. And last time I did this talk, I asked a bunch of people if I should say this or not, but all of them said yes. So I'm going to say it right now as well. If you know these like small servo motors that has a little bit of like a little like arm and actuator, you can push things with it. If that thing that this servo motor is pushing when, for example, there is an error from your observations, if that thing happens to be the pump of a bottle of fart spray, and you put this next to the developers, people are saying 100% availability is a myth. I would argue with that. Also, like profits are going up, and yeah, latency will be like very, very low. Error rate will be like unheard. Well, I'm not sure you should try it out, but it is possible. You can do it. Also, let me show you one more thing, and I believe that will be the last one. Let me stop the error generator, and let me start this with another profile. So, last time I did this, I got some feedback that some of the people were like really hoped that I will do this, and I did not. I don't want it to be very evil, but since it was a user request, I'm doing it with you right now. So, if you are musically educated and you recognize this, please stay silent. Also, so this is what can happen when the musical notes are not completely random, but they are following some rules. So what I am going to do, I am like trying to like stop or like hit this steep button with a rhythm, and maybe you will recognize what is happening here. So please listen. How many of you are recognizing it? Okay, so yeah, this is Rickrolling on scale. I believe that. Thank you very much. I believe that concludes like our talk. Oops, not that one. So thank you. If you want to like try this out, it's open source. It's on GitHub. There is a branch 2024 Spring.io, and if you have like questions, please fire them up. But you can also find us on slack.micrometer.io. Oh yeah, we have swags in exchange for questions. We have some Spring socks, Spring stickers, and Micrometer stickers, which are very rare. There are only 3 people, I believe, right now in the world who can give you Micrometer stickers, and 2 of them right now on the stage. So do you have any questions?